Hello everyone, welcome to our class today. This class is part of our Graitec Beam Up Global Digital Conference. Let's go on with our slides, and after that we will go through the software to continue our class and presentation today. So to introduce myself, my name is Farshad Porshar. I am the local product manager for Canada and US at Graitec. So I have had experience on structural engineering, and my main duties here at Graitec is like mostly localizing our software for North American market. As well, I'm doing trainings, support, demos for our software. I have also experience with development. So sometimes I'm doing development and as well doing some specifications for our software. So just to give you an overview of Graitec and Graitec products, so we have like four main categories at Graitec. So as you see, we can have like Beam products to use with Autodesk products as power packs. Secondly, we have again beams to simulate and design for real world market. Then we have the system for beam deliverables, and as well you can have the manage beam data to collaborate with external CDEs. So these are the four major categories for Graitec. Our presentation today will be focused on the second one, which is going to be like using the Graitec technology to simulate your model. So let's continue on with our presentation. So here I have opened the software Advanced Design Connection. So this is the first page of software. So as soon as you open the software, you will see this page here. So I will go fast through our options or menus that we have here. So at the left column here, you have the new project option. Then you can open a project. We have save and save as standard tools. Uh, Here you can always check the version of software. Here you have access to change units. So you can either go by default units like metric imperial. You can even import and export the units from another file. And or here you can just go one by one and select your preferred units. We have project preferences here in case you want to change the background color, the members, plates, so everything is customizable from here. To check the type of license and like expiry date and other information, you can always go here. We close the project and exit, so very standard. I will go back to new. So to start off your project, we have almost here around 225 readily built templates for you. So you can always start off your connection using these templates. So as you see, I have my main category, beam to column. Then you can go column like beam to beam connections. Then we have brace connections. You can use base plates. And finally, what I have here is a 3D general kind of model that you can add your components later on. And in case you want to start from scratch, you have this option that you can start from scratch, adding your members, manufacturing operations, and other components. So as you see, when you select the first category, you have subcategories. So in each one, so for example, for this one, I have these categories here. And if I select one of these templates and just click on create project, I will have the template created for me. So it's very easy. Normally what I ask our clients is try to use these templates to start off your modeling. In case you cannot find exactly the same geometry of your project here, at least find something similar, start off with that template, and later on you can have or modify the options later in the software. That's much more easier to do. So here we have like some other parameters here, like name, description of project. We have some default values here for materials and bolts. So these are the default values, but later on I'm going to show you how you can modify and change them. And as I already mentioned, we have design tool here in this software. So as you see, I can code check my bolts, anchors, and welds using uh, the codes or standards coming from here. So I have Eurocode, US codes, Canadian, Australian, Russian, and Chinese codes in case you want to code check your components using this software. So let's create kind of model here. So I will go with this one and click create project. So software is creating this project for me. Okay, this is the main working window of the project. So as you see here, my template has been created. I have my model here. So standard stuff here in the main window. So you can rotate, pan, zoom using the mouse keys. As well, I have some tools here to control your graphics and display. We have three types of display here. It can be solid as you see here like that. It can be transparent in case you want to check what's happening behind the plates like welds and bolts and stuff. And as well, I have another view that you can display your members as lines, so completely 2D kind of elements. So this is the main window. Obviously, you can see your design code, other properties down here. And I will go through some of the also icons up here. So as I mentioned earlier, you are not limited into just one model or one geometry in one file. So as you see here in this drop down, I can switch in between my geometry or model. So currently in this file, I have one connection, which is called connection one. But in case you want to like make modifications to this, you want to compare results, the best way is just create another one. Like you can either copy this one or create a new one. So let's copy this one. If I click copy, so now I have two of them here. I can switch in between those two and I can do modifications, and later on in the results I can just compare the results. There's no need to save it as another model, open or close it. So this is very handy tool. Here is the place that you can switch in between different types of analysis that we already discussed about it. We have undo and redo operations here. Uh, Here we have, you can activate or deactivate the labels for members. So as you see here, each member in the software has its labels. So member B is my beam here, member C is column. We have the kind of same captions or labels for our plates. So as I already mentioned, all of the members in the software are being modeled using plates, separate plates. So for example, here, this plate, which is highlighted by yellow, it's named top flange 1, web, or other. So these captions are useful when you want to define your operations like welds and bolts. But as well as you see when I'm like putting my mouse on them, they are already being highlighted and their name will be just displayed down there in the bottom left as you see. So for example, here is member B top flange 1. So very useful. And finally, I can activate my local coordinate system on my members in case we want to see them, and we can use them to apply forces. You can always take screenshots from your model, either from the geometry or results using this option here, add it to your gallery, and later on it's possible for you to use these screenshots in your reports. We have template manager here in the software in case you have created a geometry of a specific connection and you want to save it as a template and use it later on. You can always use these options here. You can just create it. You can manage it to save it, because the other good thing in the software is the templates are like files. So you can always send your template to a colleague and they can use your template to build their geometry. You have code setup here in case you want to manually like modify some values, like values related to the mesh generator or nonlinear solver. We have some values here for the factors, code-based factors, like 5 values. And as well, we have other options here, like you can stop the calculation in a specific limit string. You can have the detailing check on. So this detailing is even before analysis. Software can automatically let you know, for example, the bolt distances or distance of bolt to the edge. So all of those kind of detailing limitations, software will let you know in case you check this option. So normally you don't need to modify these options here, and default values are okay. In case we are talking about a very complicated connection, like or mesh size, you can always come back here and play with mesh size. Or in case you are not having convergence, you can always change the number of iterations and others. But normally, you don't need to modify values here. Then I have my calculate button here to calculate my model. So as soon as you just click on that, software will calculate the connection for you. We have some options here in case you want to export or import your loads from Excel. Here we have extra option in case you want to apply loads in special columns or like load bearings members. You can always add a member using this option, add loads or operations that I'm going to explain later on using these options. So in case you want to add a member, you can just click here and you will see that I have this blue member, as you see here, added to this model like this. To remove it, you can just right click here and just to delete, and there you go, that member is gone. So this was about like our top toolbar that we had here. So here I will discuss about this list here. So as you see here, we have three main portions here. The first one is the members. So as you see in this connection, I have two members. Member C is my column. Member B is our beam. Then we have the second part, which is talking about loads. So here I have one load case, which is here, and it's in this table as defined. And finally, we have the operations that in this model, I have three types of operations used to create this geometry. So each member, each load case, or even the operation has its own properties modifiable from this right column. So for example, member C, uh, it has its own properties. So for example, the first one is its cross section, which is an HP section, as you see here. So the type of geometry, you can always replace the member at top or bottom of your coordinates. You can just simply insert the values in X, Y, or Z direction, either rotation or displacement, and you can always modify the location of the member in your model. Uh, if you want to apply specific constraints to your connection, you can always do it from here. So we have the same thing for our beam. So as you see, I'm clicking here, it's being highlighted by blue. My beam is a kind of S section here. Again, almost same thing. So for example, I have my pitch here, which is currently 10 degrees. And everything related to this member can be modified using this option. In case you want to change the section or material, it's here. You can just click here, and here you have the access to shape and the material. So just to let you know, if you want to select the shape, you can go to directly to library of the sections here, which is a large library. So I have any type of mostly sections here. So we have US ones, Canadian ones, like we have even Chinese ones, Singapore, we have Russian. So almost there is no limit for the library here. You can just select here, click, and you will have the section here. Same thing for the material. So I can either go to library of material and select my material type, or even here you have the option to create customized material for your section if you want. You can just apply or define the material property values here, and software will use them in the calculation. So I will cancel these. Even we have more options for your definition of sections. If I click plus here, we have almost like other type of library here. So for these are for hot rolled sections. Here we have welded composed sections in case you want to work with those, and also we have cold form sections. So there's almost like no limitation on type of sections that you can add to your model. In case you cannot find your section here, we have also a section calculator module that you can directly start to add your sections, like for example an I section. I will just select this here, as you see. So then you can add, for example, a channel. So like this. And then what you can do is like you can always modify the location of those uh, sections using this option here. So as you see, I can just play with its location and I can create my customized section here and then assign it to my member over here. So this was just like about our members. So for the load effects, same thing. So we can have like a unlimited number of load cases to define for a connection. For example, currently I have just one load case, LE1, but you can just right click and add new load case. And as you see here, I have the table here, and you can start by applying any kind of forces in 6 degrees of freedom to your connection. And later on in the results, you have the option to switch between these load cases to see the results. Finally, what we have here, very important, is the what we call operations or manufacturing operations. That these are the tools that it will help you to create your connection. So for example, to create this connection, as you see here, I have obviously two members, but the other like welds and cuts or stiffeners that I have here, they're all automatically done operations. And as you see, for example, for this connection, I have just 3 operations. So I have 2 cuts, obviously to cut my beam and to cut my column. And finally, I have my stiffeners to be defined here. So you can always activate and deactivate them. Like for example, if you want to see what's happening without stiffeners, you can just deactivate or remove this check mark. And as you see, the stiffeners are not there anymore. I can put them back here. Or even for cut options, like you can see what they are doing. So the first cut is cutting member C by member B. And if I remove it, you will see member C is not cut anymore. And I will just put it back and it's there. So each operation, like other members or load cases, has its own properties listed here. For example, connection like cut 1. Here I'm asking the software to cut my member C, which is my column, using member B, which is the B. And as you see, for example, this sloped cut here, it's coming from this definition. We have bounding box, and you can ask this, the operation to cut it farther or closer to the edge. It can be parallel or perpendicular. You can even define an offset for the cut as for example, here I have 1 inches. So these are very useful options to use this kind of tools, or even cut 2. It's to cut my member B with my column, as you see here. So, and these operations are very, very modifiable. So for example, here I have defined my welds. So you can define flanges and web welds separately. So in case I want to remove the weld for my web, the only thing that I need to do is go to here for the web and remove the weld. So as you see here, I don't have any more weld here. You can remove it for flanges as well. So it's very easy to use. I will put them back. So the operation is very easy to use. Same thing for stiffeners. So as you see here, I have a stiffener operation. So everything related to stiffeners are being defined here. So it's on member C related to member B. So software knows that it should follow the flanges of my member B for the stiffeners. You can put the position in lower, upper, or center, or both. So lower, as you see here, I will have it in lower flange. You can have it in center, as you see here, or I will just put it back to both. So you can control almost everything regarding the stiffeners here, even the location. You can have it just in front, as you see here, or like rear, or you can have it in both sides. So everything is modifiable. The other nice thing about this operation is like they are completely interactive with your changes. So they will follow. So let's say if you want to have some changes in the sections, you don't need to define the operations again and again and again. For example, if I decide here for my member B to like change the slope, I can go to member B. It was 10 degrees, so let's say I want to put, I don't know, 25. So as you see here, all of the operations are following. So you don't need to go back and define them again. So any changes on member, all of my stiffeners or cuts are following the changes in member B. So this is very handy and easy to use. So I will put it back in 10 degrees. So these were like just two types of operations in the software. If I right click and go to new operations, we have all these types of operations in the software. So for example, the cut was this one was the stiffener, but let's say we have automatic operations to add wideners or ribs, any type of openings like splice plates. So everything, even gusset plates, end plates, everything that you see here, you can just create them automatically. This is a manufacturing operations and you don't need to do them manually. In case you want to add manual stuff, yeah, you can add like members, plates, you can add individual bolts or welds to the model in case you want to create a model manually. But most of the time you can always find the required operations from here. So for example, just to show you another model, I can just select this one, which has also bolts, create project. So as you see, like for this connection, one, two, three, four, five types of operations has been used. So everything is through operations. For example, like the widener that you see here, if I remove it, you see it's not there anymore. I will put it back here. And this is the properties related to that widener here. Okay, so we talked about like geometry in this part of the presentation. Now let's do some analysis and move on to kind of reports. So what I'm gonna do is I will just use this geometry for my calculation. So as you see, the forces are being applied here. I have bolts and welds, and what I'm gonna do is just select calculate, and we can calculate this connection. So as you see here, software is nonlinear, so it will go through some iterations. I have the results here. So first of all, after calculation, we have some preliminary results. As you see here, we call it like overall check results. The colors that you see here, it's kind of follows the traffic light colors. So in case you're seeing everything is green, uh, it's okay, it's passing. If you see something like orange or red, software is telling you that okay, something is not passing, there's something wrong with the connection. So for example, for this one, as you see, like there's nothing red or orange, so this connection is passing. We have also some information here. So for example, here I see that analysis has been done 100%. These are the work closure of plates, bolts, and welds. So this is telling me that the connection was able to take all of the forces 100%. It's possible that if you're applying very, very high forces, software cannot converge, so connection is not able to take those forces, so you may end up with smaller values here. But for this connection, we are okay. So then after this, I can just switch on check. It's going to be check my results. So the other type of check that we have is strain check. So I have some strains here. Nothing's too high. It's just 0.56% of my plastic strain, which is happening in these areas. You can check the stresses. So these are my stresses here. I will just activate my mesh. So this is the mesh. So as I already mentioned, all of the contact elements, uh, all of the elements around the bolts, even the rigid links or spring elements are being defined automatically. Even the welds, as you see here, are being meshed and created automatically using these special elements. So the software is like it's very easy to use because, as you know, like for if you're using another finite element software to create this type of complicated components like bolts and weld, it will take you so much time. But the good news in this software is it's all being done automatically. So here I'm seeing that, yeah, I have some high stress points here at the top and in web of my column. So you have also the form shape. So if I activate it here, let's go to side view. So this is the deformed shape of my connection. You can always play with this scale of the deformation, as you see here. And as well, I have the results for plastic strain. So it's being developed here. Yeah, I see around the bolts at the top. These are the kind of plastic strain. You have the strain limits or values here. The other type of results that we have in the software are bolt forces. So let's say if you want to see the actual forces in bolts, what I can do is just go here, and here software will display me the forces in bolts using these black arrows and the value. So for example, here it's taking like 17 kips of force this specific bolt. So these were like kind of geometrical results in this software. Now let's go through for like some type of design results and tabulated. So those are here. So first the plates. So the plates that we have here in the software, you can either view them 3D here, or you can go one by one using this tab here, table here. The good thing is you can have them separately and you can have its maximum values separately for each plate here. So for example, for this plate stiffener, here you can see, okay, maximum sigma value is 36 KSI and epsilon is 3.8. So you can go through them one by one to check what's happening for your plates. Okay, we have results for bolts. So each bolt here, as you saw in this model, we had 6 bolts. So I can go through them one by one through this table. You have the values here calculated. So these are the work ratio of each bolt in tension and shear. You have the internal shear and tension listed here for each bolt. And you have their resistance based on the selected code from here. So forces, resistance, and work or utilization percentage in this table. In case you even want to have more details, like how the resistances have been calculated, you can just click here on this plus sign, and software will show you the clause that it has used for this calculation. So for example, here I have selected a Canadian code. That's why I'm seeing these clauses. If you are on US codes or other codes, you can always see the related clause numbers here. So it's not a kind of black box. You see the class number that software is using. You see the parameters that software is using to check for specific criteria for this bolt. So, and I have this results for all of other bolts as well listed here using the each clause number separate. And then we have the same thing for our welds. So again, my welds, uh, you have them separate here. So you have the internal forces, the resistances, all of the related properties, the lengths of the weld. And in case, again, you want to see how it's been calculated, you can just click here and you will have the clauses related to the welds here and the parameters and the calculation that we are using to design this type of weld in this connection. So these were also like some results based on your design. Then what I can do, I will show you the report generator. So if you want to have a report, you can just click here, report. Software will start to create a report based on a default template or default format. So as you see, I have my sections, a 3D display. You have like some material properties, bolts, some figures from results, internal forces, and just this. So the the default template is very short just to get some results, but I can also create much more longer uh, reports, like more detailed. So it's controllable from here. I can just put all of these to create much more detailed results. If you do refresh, software will start to generate a new result, a new report. Okay, the new report is generated. So now you will see much more details in this report. So for example, all of those design formulas that I've already mentioned are listed here. And as well, I have some others here. There you go. All of the formulas. I have bill of material table here. And of course, I have like drawings here, which is like very useful in case you're planning to send your model to a fabricator. So you have all of these drawings of your plates and bolts in the connection and their dimension. So the good thing also is here, you can always send these drawings using the XF format. So let's say if you have a drawing in AutoCAD and you want to add these drawings to your main drawing, you can just export them as DXF and import them into your main drawing. So you don't need to like draw them or like create these plates again in your main drawing. So this is how a report works. So what I'm going to just show you as maybe a kind of final tool here is just I will go back to design. So if you are working with base plates, we have also base plate modules here. So I will just use my template just to show you a base plate here. So it's a kind of specific operation. You can just select create project. So this is a base plate. Its properties are listed here. So you can always modify the concrete, the anchor, even the base plate itself, the weld. So everything is modifiable as my base plate operation. I will just run the analysis to see what kind of results it can provide. Okay, there you go. So as you see here, my anchors here, they are not passing. And if you want to see more detailed results for base plates, so first of all, we have concrete check here. So if something is wrong with the concrete or it's like overly stressed, software can warn you here. Then we have stress in concrete. It's coming from here. So as you see, I have this type of stress here under my base plate on the concrete. And I have also the anchor forces. So these are type of results that you can check always for base plate design as well. Here we have some 3 more result tables. For example, so we have the anchors and all of the detailed calculation for anchor design. We have concrete block check. And finally, we have the shear check for the base plate resistance check. So these are obviously related to Canadian code because I have selected CIC, but if you're using other countries' code, you will have them based on that country. So this was kind of like our demonstration inside the software. Okay, thank you very much for your time. I hope you have enjoyed this webinar and you have learned some good tricks using this webinar. So now what we can do is we can move on to your questions.